Okay, so I'm putting this video together to kind of talk about how to convert vectors to different coordinate systems. I'm going to kind of start right off the bat with kind of some dense material, and then I'm just sort of going to backtrack and go over how to do these dot products for just kind of vector to vector. So, okay, so first off, so say we have a vector here where we just have like x in the x hat, y in the y hat, and z in the z hat, and we're trying to convert cylindrical, spherical, etc. We can use this table. And we can say we have our x component here, where I'm getting this from. So this is the magnitude, right? So the magnitude here, r cosine of phi, y, the magnitude is r sine of phi. And then we're taking that magnitude and converting it. And then we're multiplying it by the unit vector in that direction. So if you look down here, this is our x hat. So this is x hat. This is also x hat. Say, for example, you have like x squared, it would just be like this r cosine of phi squared, etc. So like if you have a different kind of variable expression. Okay, so we have x hat, and then this part we see is also y hat. So we're going from Cartesian to cylindrical. So Cartesian to cylindrical. So y is this r sine of phi, and y hat is this sine of phi r hat plus cosine of phi hat. Okay, and we see that here. Z is just the same from Cartesian to cylindrical, and so we see that right here. Okay, next we're looking at this A to spherical. So you have this x hat first off, so we're going from Cartesian to spherical. So we're first subbing in the magnitude for x, so magnitude for x, and then we're subbing in the direction. So this is the direction for x. So this is the x hat direction in spherical, and I kind of put these arrows for where they're coming from, and that's where we got these expressions down here. These are obviously, I mean, what you would do is if you had this whole vector expression and you wanted to recombine these pieces, you would want to multiply these out and then combine like terms. So combine all of the r hat terms and all of the phi hat terms for this. For this one, the same thing, combine all of the large r hat, the theta hat, and the phi hat terms. To put these back together. So I have the cheat sheet up here that we're referencing. So I just showed you the piece from Cartesian to kind of everything else, but we could also go from cylindrical to everything else and spherical to everything else. Exactly the same approach, exactly the same kind of logical process. I want to take a second to look at problem 212 to kind of talk about how we're going to use that table up there to convert and dot unit vectors in different coordinate systems, and also to cross unit vectors in different coordinate systems. So I, for the sake of time, looked up and wrote these out, but I'm going to show you where they come from. So, okay, so for example, I have phi hat dot x hat. So this is just sort of a different way to represent these with the a's, but it means the same thing, phi hat dot x hat. So my process to solve this is I want to convert one of these unit vectors so that both of the vectors are in the same coordinate system. You could pick either. In this case, I picked x hat. So it depends. So at the end, we're going to have everything in the cylindrical coordinate system. If you want that to go the other way, then I would convert phi hat to Cartesian. Okay? But in this case, our final result is going to be cylindrical. So I looked for x hat and then the cylindrical version of x hat. So I got that from the table up here. So I started with Cartesian, and I have x hat. And then I took the cylindrical version, the unit vector for cylindrical. So I converted this unit vector to cylindrical. So this is the equivalent, and then I'm going to use it in my problem. So I have phi hat here, and I'm going to dot it with this x hat vector that I found, and I'm going to remember the unit vector rules that I wrote up here. So if I dot a directional unit vector with itself, my magnitude is 1. So this is the same for like a phi dot a phi, etc., or like any of them, any of the directional unit vectors, it's equal to 1. And then if I dot a directional unit vector with one that it's perpendicular to, it's equal to 0. So on the side here, we can look at which vectors are perpendicular in their respective coordinate systems. So these guys are all perpendicular because they're directional in their coordinate systems. So the same rules apply to all of the perpendicular vectors in all of the coordinate systems. If we dot perpendicular vectors, we're going to get a 0. Okay, so let's see that. Okay, so we have phi hat dot r hat. That is in the cylindrical coordinate system. Phi hat dot r hat, those are perpendicular. That means that we get 0 when we dot them together. So phi hat dot r hat, we're going to drop out this cosine term here. That's going to go to 0. Oops. Going to go to 0, and then we're going to end up with phi hat negative sine of phi and phi hat dot phi hat. They are two directional unit vectors dotted with each other, so that is equal to 1. So our answer is negative sine of phi hat, or negative sine of phi, sorry. And dot products do not have a vector direction, so this is just a magnitude, phi as a magnitude. Okay, let's go on to B here. So same approach. Our end result is going to be in spherical because we converted our y to spherical. If we wanted our end result to be in Cartesian, we would convert this to Cartesian instead, but it's up to you. You could go either direction for this. Okay, so AR dot AY. So we found the spherical representation of our y hat, and we got that from our chart. So we started with Cartesian y hat, and then we went and we got the spherical version of the unit vector. So the spherical version, and we saw that on the last page when we first started. Okay, so, all right, so we have our hat, and we're going to dot it with what we found, and we're going to apply our same rules here, okay? So all of the directional unit vectors in a coordinate system are perpendicular to each other. So these guys are perpendicular, r hat and theta hat, and r hat and phi hat are also perpendicular, which means those terms will cancel. So we're just going to end up with this first piece, so sine of theta, sine of phi, r hat dot r hat, which is equal to 1. So we're going to end up with sine of theta, sine of phi. Okay, and that's our solution for that one. So canceling is a nice thing. It helps us make our problem a lot simpler. Okay, so and the dot product is bidirectional, so you can dot like a dot r with a dot z, like you can switch the order and they'll be the same. That's not true for the cross product, but it is true for the dot product. Okay, so we have same thing here. So I converted z to spherical. So I went up to my chart here. I found z, okay, and then this is in Cartesian. So I found z in Cartesian, and I want z in the spherical coordinate system. So this z hat here. If I had a magnitude for z, like if I had z multiplied by z hat, I would do this, kind of what we saw in the beginning. So the unit vector for z, unit vector in spherical. Okay, and now I'm going to use it. Okay, so I have cosine of theta r hat minus sine of theta in the phi hat. I accidentally just made my pen thinner for no reason, and then I'm going to dot that with r hat. Okay, so same rules apply. I'm going to cancel this term, right, because these two are perpendicular to each other, and then r hat dot r hat is equal to 1, right? So basically all I have left is cosine of theta. That's my answer. Okay, I'm going to just check these guys really quick to make sure that we're getting the right answers here. Cosine of theta, yep, we are good. Okay, so we did all of our dot products. Okay, now let's look at our cross products over here. So same approach, we're going to pick one of them to convert, and then our end result is going to be the coordinate system that we chose. So we converted x to cylindrical, so we're going to have cylindrical cross cylindrical, and we're going to stay in, our end result is in cylindrical. So same approach, we're going to find x in cylindrical. We could also find cylindrical, we could also convert this a phi by doing the same thing, but we're going to do it just this way, just because I chose. Okay, so we have this x, but we'll get the same result either way. We might have to convert it at the end, but okay, so we're taking this x and, okay, so we start in Cartesian, right? So start in Cartesian, I have x, and then I want the cylindrical version, okay? So, for example, if I started in cylindrical and I had IR and then I wanted Cartesian, I would do kind of this. If I started in cylindrical and I had I phi and I wanted Cartesian, I would select this, okay? All right, so, okay, so I have phi hat, right, crossed with this piece here, copy, paste. Okay, so for this one, for our cross product rules, I put them up here, but if I cross a vector with a vector that it's perpendicular to, it's going to equal the other vector or the negative. So for example, in this case, I have phi hat cross, here's for cylindrical here. I have, okay, so phi hat cross r here. So I have r cross phi is positive z, which means that phi hat cross r, little r, is going to equal to negative z hat because the direction matters, and it's just the right-hand rule. So it's like if you cross them the opposite way, your thumb is pointing the opposite direction. If you have trouble remembering that, just kind of keep this chart and then note that if you swap them around, then you just have to add a negative. Okay? So we're going to get z hat, but then for the cross product with itself, we're going to get 0. So, so we'll put that over here. So phi hat cross phi hat equals 0, but then this phi hat cross r, and the direction matters, is going to equal negative z hat, okay? And we got that from up here, but because we swapped the order, that means that this is negative, okay? So just, if you want to look at the table and just remember if you swap the order that's negative, that works as well too. They're all up there. Okay, so phi hat cross this one, so we're going to end up with cosine phi in the negative z hat, because these guys canceled, this piece canceled because of this, and then this one, we just changed our coordinates here. So the cross product is a vector. In the end, you'll have a vector direction, and we see that that vector direction is z hat. Okay, so we're doing this guy here next. Okay, so we decided to convert r hat to cylindrical, so our end result will be in cylindrical. You could do it the other way around as well, but this is just what we chose. Okay, so r hat cross r, so r hat cross sine of theta, r hat plus cosine of theta, z hat. And then we got this from up here. So we started with, okay, so we started with spherical and we wanted cylindrical. So we'll go up to our chart. So starting with spherical, and we had spherical, and we had r, and we want the unit vector. This is the unit vector, these are the magnitudes. So we wanted the unit vector, and we wanted it in cylindrical. So we took r spherical, and then we got the equivalent of it in cylindrical, so the equivalent unit vector. So sine of theta, cosine of theta. Okay, so just pointing out where that came from. Okay, so crossed with itself, so r cross r, right, equals 0. R crossed with z, let's check over here. So it's going to equal our other coordinate, so r crossed with z. So r, we can look at it on here too if we want to. R crossed with z, so we're going to get phi, and that should be negative phi. So if we think about our right-hand rule, we can kind of visualize it here, but we can also look over here. So r crossed with phi, r crossed with phi here. So, oh, sorry, oops, I did that the wrong. Did I say r crossed with phi or r crossed with z? Yes, r crossed with z, sorry. R crossed with z, this guy. Okay, so z crossed with r is positive phi, but because we're swapping them, it's going to be negative phi hat, okay? And we can visualize it over here. So right-hand rule, it would be negative phi, right? Okay. So r crossed with z, negative phi, so we're going to end up with cosine, and then, sorry, this guy cancels, right, because of this, and then we're going to end up with cosine of phi cosine of theta, sorry, in the negative phi hat direction. I'm just checking that. Yes, that's correct. Okay. All right, and then doing our last one here. So a phi cross az. So we have phi hat, right? And then we're crossing it with our converted z hat. So we are in spherical. So we went up, we started with Cartesian here. We could also start with cylindrical because z is also in cylindrical, but we'll note that they're the same. So I'll show you guys here. So like z hat in Cartesian. So I want to go from z hat in Cartesian to z hat in spherical. Or if I go from z hat in cylindrical to z hat in spherical, note that they are the same. Okay. So starting with z, okay, and I want to convert to spherical, I would just select it here on the chart. Okay. All right, and let's do our cross product here. So, okay, theta cross r, all right, and we're in spherical, so we can find it in two different ways. So theta cross r, so if we think about our right-hand rule, we should get negative phi, right? Theta cross r, pinky in this direction, sweep your hand this way, and then your thumb is going this way, right? Would be negative phi, but let's look over here. So theta cross r, okay, so we have this guy, so r cross theta is equal to positive phi, and then when we swap them, we just get a negative, so that would also be negative phi. Okay, so negative phi, so theta cross r is equal to negative phi, so cosine of theta, negative phi, right? But then theta cross theta, theta hat cross theta hat equals 0, and we'll have this, sorry, theta cross r equals negative phi, r cross e, negative phi also. Okay, and just checking, and yes, that is correct. Okay, So we kind of went over how you did these unit vector cross products. Just kind of a high-level overview. I will post this in the description on the video, so you can kind of have this as a reference and just kind of a sheet to look at.